you have to learn something. Otherwise, you have to come back next year again. Although I don't want you to come back, but you choose to come back. I cannot do anything. Continue. So we were talking about this one. The first one we talked about was the temperature, right? So we correct the temperature. Now we are going to correct a second one. It's called poor force. But idea is the same. The idea is so. Let me unify the one is a P. I used to call it a force, but it's a poor force. Okay, so do the correction for the CP. From the one, if you still remember, is AE, the cross-section area times the modular, Young's modular, and then is a P minus P no. P is the observation, the force you exert, and then the L is the nominal distance. Okay, let's do this correction. Do the correction. So L is over here. This is L. Nominal first. Nominal distance over here. You can do the correction over here. No problem. This is L. So we get L already over here. And P is force you exert. How much force you exert now? You exert a lot of force. 145 newtons. So this will be 145. What's the standard Newton force? Standard Newton is 95 Newton. So this is 95 Newton. The cross section area is I think it's here. Cross area. So this is your A. This number, this value is your A. A is a cross section area of the tap. So it's 3.35. Sometimes you have to convert, you have to unify the units. So it's millimeters. So maybe they have to convert to meters. It depends. If this is meters, maybe this one has to be convert to meters as well. Let's see. Okay, so you also A. You got A. Now is Young's modulus E. So Young's modulus E is this one. So you have some weird unit over here. Don't care about it. Just write down. Take care about the numbers. You can forget all this weird unit as well. N stands for the Newton. This M probably is M. I try to find out M. M probably is mass or something. Anyway, let's continue. So everything is settled. Everything settled. Just substitute. So this is Newton force you exert 148 and 45, and this is a standard one. Standard one is 95 newtons over here, and then is 119. This one is your L 119.631. This is L. This is nominal. This is your nominal distance. And then this is your cross section area. Cross section area is over here. So this is a value is over here. A over here. 3.35 over here. And 1.14.8 times 10 to the power 4 is Young's modulus is over here. Anyway, supposedly it seems that now is also compatible for the units, but at some point, if that is not compatible, you have to really go into all the units. Look at units. We probably will keep the units as intact, but sometimes you have to change the unit as well. In this case, you have to convert them to other units. Okay, so the correction for the force will be 0.0121. Now comes the next question: are we going to deduct or add up this value? Take a look at the force. This force is standard force is 95. My force, I exert the force is 90/45. So it means what? It means I elongate my nominal measurement. So it means it's supposed to be longer. If I use the standard one, I supposed to get much more physical units. It means you underestimate. You use this one. You underestimate. You pour it. So this one become too big. You underestimate. So you have to get your head wrong. You underestimate. So since you underestimate, you have to add it up. You have to get this one in order to get a standard one. So you have to add it up. So the sign will be positive. So the final one, you're going to get a positive. You can also get a absolute value for CP as well. In order to save your brain, at least that's the way I'm doing now. I know that. So this is your error, and eventually your standard one. Of course, this is just if you look at this one, this just consider the temperature. You look at this one consider the pull force. So eventually you put them together. You have to put them together. You have to L plus this one minus this one, and that will be final one. But if you only took at this one without regardless this one, then in this case you only get this number. So L will be 191. This one, this is your L, this is your value, and the CP is over here. Okay, so eventually, if you consider the force user on this one, you're supposed to get this number plus this number. So how much are you going to get? I leave it for your calculation. Easy to do a calculation. Okay, so far so good. It's not too complicated, but it's just you have to if you want to get a minus or plus, you have to get your head wrong. Normally you get it wrong. Okay, so now consider about only these two. Correction for temperature and correction for the pull force. How much are we going to get? The final result will be LS. If you only consider about these two, the final result LS2 will be how much? L. And correction for the CT. CT is the temperature. Correction for the CT. And then correction for the correction for your CP. This is CT. This is CP. The pull force. In this case, this is not a general formula. This is just for in this particular case. Every case different one. This side differs. Every case differs. So this one. So plug in L is over here. CT is over here. CT is you calculate CT over here, and CP over here. I put the absolute value, and then you'll be fine. Then it will stay fast. It's easy to understand. At least for my approach, it's easy to understand. If you have your own approach and you can get it correct, it's also fine. It's just my approach. I don't want to use too much brain, so I just set an absolute value first, and I only think about this bit, positive and negative. And this to be positive and negative is easy. I just think about the normal one, how to do the comparison. You'll get it whether it's a big or small. So far so good. Right? Let's continue. This is a good example. This example pretty much go through every bit. Now comes to what's called sec correction. What's called sec correction? Sec correction, look at this one. If the tab is too long, you don't pull, you don't exert enough force, the tab will be soft. It's called sec. It's a sec. Then this we create. This will create some mistake. So for the sec, normally this if you use this one, this is your nominal distance. The nominal distance you underestimate. You see, you underestimate. So in the end, you must pass this one, this value. You pass this value. In the end, you pass this second one because this one. But standard one must be this one. This is a standard one. Standard one, straight one. So if you use standard one, you tend to have this error. You tend to have a high one, but since you choose this one, this one, you have a low one. You choose a low one. Let's take a look at the sec bit. Let's go back a sec bit. Hopefully, today we can at least finish the sec bit. So that's pretty much the main one for correction for the distance measurement. Others, I think. You can use others as well, but they are not as usual as the one we are using. So let's go back. There's some explanation regarding the sec. Okay, this is a correction for the sec. Take a look. And this is the sec. The course. This is called catenary. This is called catenary. Catenary is a sec. Normally it come from the secondary. Okay, so this is called sec. So this is your nominal one. This is your nominal one. Okay. So this is one. If you use this tab, you're supposed to get this one. And if you use this tab, you overestimate. Oh, so I probably make a mistake. This is overestimate. Overestimate because you put this one. So the number you're supposed to put this one. You pretty much you overestimate or something. Okay. Let's see how to do the correction. The correction based on three factors. These are three factors. Let's take a look at the three factors. First of all, L is a nominal distance. Of course, every correction in regard to the nominal distance, you have to correct this one. And you have W. W is what? W is weight. Maybe it means a weight force. Is a weight per span length. It means this is one span. This is called one span. Second span. Third span. So you look at the weight of this span. It means the weight of this tape. You measure the tape, the weight of this tape. What's the weight of this tape? So it's if the weight is high, then the sack will be much more heavier. It will become this heavier, right? If you have a weight because it's heavy, so you have a pull force over here. The pull force comes from gravity. So gravity will pull. So this is called weight force. The weight force of including the mass and the gravity. This the W is the equal weight force is gravity plus the mass. Okay, so it's proportional to W and also to the square. So it's exponential proportional. What's P? Take a look at P. P over here, I think, how come is there is no P? There is no explanation. I think it's used to be written somewhere. So we can this P must be if that is the correct one. Let's see this one. This tab is a weight. You have a W over here, right? And tab standard and if I this correction stack is this one. Okay, we'll check this P later, but there is also a P over here. So and this is whatever. So this cause a lot of segment, a lot of sag over here, a lot of sag over here, so heavier, and the correction will be this one. Let's go back and let's see how to do it and memorize these two picture. This memorize this. This is one category. You have many ones over here. So these have three spans. Here have only one span. Every span will cause some distortion. So you have to add up all the distortion span by span. So this span will maybe it's heavier in this bit. They will have a higher span. Maybe it's over here. So different span are they different. Okay, let's go back. So the idea. Memorize this one. And so let me take a picture of this one, and then we can come back at this one. So take a picture of this one, and also take a picture of its explanation as well. It's an explanation. We'll get the meaning of P in the example. We'll get the meaning of P in the example. Okay, I leave this one, then I can easily check again. Okay, let's go back. Let's go back to the one, the second one. Okay, this is a set correction. So now, how many segments do we have? Go back to the initial one. Initial one, you have a four span like this one. So you have a span over here, span over here, span over here. You have so span. Every span. This is the length for the span. Okay. So let's go back. So in this span, indeed you already overestimate. So you deduct the sag because if you use the same tape, it's supposed to be here. Now regardless of the standard tape, just look at the tape itself. The tape is supposed to be strengthened. Like this one, it's supposed to be strengthened, but instead it's a little too heavy. So it's meaning the gravity pulling down. There is a pull force over here, so being pulled down. So it causes some distortion. So, but indeed, it's supposed to be this one. If this one, it won't cause to suppose it's 20 meters. This is 20 meters, and the real one, that's now have nothing to do with standard tape. It's just the same tape. You look at the same tape. If we use this tape, the same tape, it's supposed to be strengthened one. Strengthened one, the reading might be 19.5 meters. Right? It might be 19. But indeed, because you have a sag over here. So this one, the reading is 20 meters. So it means there are 0.5 meters overestimated. So for the sag, had nothing to do with standard tape. It's just the tape itself. So bear this in mind. So this is slightly different. Previously, talking about temperature, talking about force, they are all the correction related to the standard tape. But now it's not a correction related to the standard tape. It's just a correction for itself. Itself is supposed to strengthen, but instead it don't pull enough. So it causes a sag over here. So in this sag it causes some errors. So you have to correct that for its own tape. Let's take a look. So the sign will always be minus for the sag. There is no impossible positive. It's always minus because you always overestimate the reading because it's supposed to be strengthened, but you don't put it straight, so it's become like 20 meters. So always, remember, sag is always -1. And I remember I sent you guys one picture. There is one sign setting is always what I think we'll find out that one later. But let's continue or come up later. Okay. So now we're going to correct the sag. So based on depends on which one are you going to correct one. So it's better to correct the sag first to make it normal by itself because it's by itself. And then after this correction, it starts to do all this piece. In some sense, this error is better to be to be the one that corrected self-corrected error. Because okay, let's go see how to correct this one. And this is our formula. You can think about minus positive, up to you, because we are going to put absolute value on top it. And then we don't have to think about positive, negative. You just choose whatever you like. Just write that. Anyway, it's always positive. This number. If you don't put a negative, over here, it's positive. Maybe a minus. Okay, so you have an error. This is an error itself. If you cantilever a segment, if you use the tape of a segment tape, you'll give an error segment, the sag. But indeed, this is after the sag, after deduction. So this is a correction after the sag. I will do some correction after the sag. You get this one. So suppose this error is better to replace this error. But this error you haven't considered about the sag. You haven't correct the sag, so you start to put this one. But it's better to correct them first before you execute all the temperature correction and poor correction. It's better. Okay, let's continue. So how are you going to do now? Now, how many span? This is also not very accurate terminology because it doesn't mean one error. It means many errors. And on the other hand, we use the other formula. The other formula is called I think it's omega. This is W. This is weight force. This equals I have a derivation, but now let me check whether I can find my derivation. I put it somewhere. Just let me hold on. I think I have derivation for this one. From the derivation, you can easily see. Hold on. Okay, so normally this W can be written like this way. It's called the weight of the tape per span length. So this W normally you can replace like this one. m g or indeed here is m is your mass, g your gravity, and there is a there is one, I think it's a small error over here. In this case you write big error, but in this case you write small error over here. Right, small error over here. Okay, so this is your one span of so what does it mean? It means error basically they relate to this one. This one is related to this one, the one you measure, the one you measure. So it's the correct that one. So the first one, look at the first one. The first one you measure is 29.9888. It's over here. It's 20. I think it's already put everything together, so you cannot see any of that. But I'll explain. I'll explain. So here is the one basic is look at the one span look like this one. So this is your error. This is your error. The reading from your this one, and this is the mass, and is all small one. Oh my god. Suppose this is L1, and this is your weight force, the mass times the gravity, and the mass times the gravity. Okay, put them together. And so you could so this is the first span, and also correct this L1. Now is being taken into pieces, not a combined one, every one piece. Then you do the second time, the second span. So you correct one span by span. There is one span here. You correct this one, this span first. Then you correct the second span, and then you correct the fourth span. In total, the fourth span. I correct fourth span. Something like this one. Okay, correct that. Okay, so after you do correction, this way according to this one, I do. So in total, you can put the L1, L2 outside. So L1 become L1. So eventually you will raise to a power of 3. So you can put them together, power 3, because this one already is omega L. So this is mg is omega. Here is omega. Is a weight force. Omega stands for the weight force times L. Times L is a length. Weight force times L. Over here, this one. Become this W. So W is not weight force itself. Weight force is omega. W also has to include L1. So in some sense, it's more like force, more or less like a force. Because this L is moving this direction, rather than this direction. So you can't say it's the force itself, because the force is the work. I'm talking about work. The force is exerting in this direction, but it's moving this direction. So it's hard to define this one. But anyway, remember this W defined by this one. The omega times L times L1 is defined to be the some sort. You can treat this W as work. Okay, let's continue. So basically, you can do. Let's find out the omega. Omega is the mass over here. This is mass. So omega basically is mass times your gravity. So mass is this is your mass. This is your mass. Mass of gravity. Mass means is regardless of independent of the gravity. So you have your mass over here times your gravity. This gravity is 9.8 newtons per square meters square. So and this is a square as well. So this is omega. It is called weight force. This omega is a weight force. This omega is called in physics is called weight force. Weight force is the force, the gravity force exerting upon the mass is called weight force. The force comes from the mass of the object with a weight force. Okay, so this omega here is a weight force, raised power 2. So you time this one is a weight force, weight force. Okay, and the raised to power of 2. Weight force is pretty much is a 1 on the scale. On the scale, if you put up a scale, it's stand on top of it, so you will get this number, weight force, and then L1 to 2, it pass. L1 is over here. L1, L2 is every individual. You raise the power of 3. So it comes from this derivation. Of course, you can forget this one. Individually calculate every individual one, and you get this number as well. Get this number 1, but it just takes too much time. So it's better put them together. So you can just treat this one as the formula, as your formula. So next time you can, instead of memorize this one, you can just memorize this one, because this one contains less information. This one has much more information. So omega is the weight force, and L1, L2 is the measure one span. This one L1, L2. This is your L1. This is your L2. The reading from the second measurement. Reading on the second measurement. So this L1 plus L2 up to L4 over here. Raised power 3. And then you put them together. You can easily get this correction for the sec. Okay, so now we are going to do this correction. You have to correct this one. So how are you going to correct? Without looking at temperature, looking at the poor correction, you look at this one, solely look at the sec. You are going to, how much you are going to correct? You are going to correct is this is your second measurement is 119 something one. So this is a 119 point. Now we don't talk anything about temperature or anything, just purely look at the sec one. And of course later on we'll come to temperature as well, but now another story. It's 119.631. Or maybe I can let you show it as a homework. Minus the absolute value of your sec correction is 0.01 something. It's always minus. There is no positive here. Always, because the sec is you overestimate something. You have to deduct it from your this overestimated value. So in total, you can get this value, or you can get it. This value is your error. It's still in error. It's still nothing to. You haven't correct the temperature. You haven't correct the pool. You just you correct the sec first. I prefer to correct the sec first. Before you do the temperature, and since this has been corrected, so once you want to consider these two corrections, you can replace this error, replace with this error with this error. So this error will become the new error for you. So do the segment bit, because it's a tab itself. It's the same tab, but this two is related to the standard tab. So these two you have to consider especially individually. But this one is the tab itself. So it's better correct this tab itself first. Suppose you pull it harder, then you get something much more accurate. Then this will become your error. And then later on correct this error, because it's influenced by temperature and poor correction, poor force. Okay, so I think it's easy to understand. So this is called sec. So if you want to put the three forces together, temperature, pool, and this one, just like I say, it's easy. You just replace this one, this error, replace, do the segment first, replace this error over here. And then correct the temperature and the pool correction. Okay, so I'll let you do this one as homework. So far we have done. And let's continue. Slope correction, we did it already. This is a slope correction, and this slope correction looks a little bit from our usual one. This is I think is a estimation. You don't need this one. You can straight away use the one we told you, the cosine one, to see the value of cosine. But here is the value. Here is there's something called a level. You see the level over here, difference in level. So the ground is not even. The ground is not even. So there is a difference in level. So take a 0.346. 0.346 is over here, the first one. The first one. Then second one is 0.214 is over here. Make it as a square every number of them. You can take this one as you like. Indeed, it's better to do the correction as well. Do the correction as well. And this is a good writing as well. I don't know. He always write one error to stand for 4 errors. Now he's supposed to have 4 errors. So it's better to be written like you have H1 is H1 is your over here. This is H1. Is your level. So it means the ground is not even. Your tab is so it's a slope. It's not even. You're supposed to put a tab over here, but the ground is not even. So there are some discrimination for your angle cost. So this is H1 is H probably stands for height. So there are some height is 0. H1, H2, H3, H4, H1, H4. And you do some correction. This kind of correction, I don't know what we did it or not, but indeed you don't have to. You can use the cosine value straight away. Do the one, but you can also apply this formula if you like. You can also apply this formula, but it just must apply correctly. So this is 1/2. 1/2 the level. The level H is the level raised to the power of 2. And this one, this value is your L1. L1. You sum it up plus the second one, the second measurement. The second one is H2 square and L2. Okay, and the third one, so on and so forth. In total you have 4. You have 4 one. You put them together and use this formula. If you are interested, you can look back at the book and find out this formula how we become this one, because we used to have a cosine at times the slope, and now it give you this formula, and you can check how this formula come out. If you can't find it, you can let me know and I can derive the formula for you. But you can check the book and see where you can find. I bet it's in a book, but if you can't find it, then let me know. I can derive this bit for you. Basically, it's based on the sine cosine bit. So you don't really in particular need this one, but it's better if you have some. Okay. Now next one, probably the last one for our correction. At least for our correction, we don't need. Of course, there are a lot of to be corrected. Million, billion, a lot of. So it's endless story. But all these are the usual one. Usual use a tape. It's usual. They are highly influenced by all these people. So now let's come to something called mean sea level correction. What does mean sea level correction means? Mean sea level correction means you want to correct. For example, if this is the Earth, a segment of the Earth, and you want to measure. This is more like Earth over here. The sea level. What's the sea level? You look at the sea. The surface is called sea level. This is sea level. So you are much more interested. I want to measure the distance between A and B in the sea level. But normally you are not measuring things on the sea level. Normally you are measuring things on the ground level. You set up the level. You ever set up something, or maybe the place you stand is higher than the sea level. Of course, it's higher than sea level. You are standing in the sea, something like that. Maybe not. In Netherlands, I heard most of the ground under the sea level, so not necessary. But anyway, a normal one, I look like this one. Let's go back to the textbook and to the main body, and then take a look how to make this kind of correction. Idea is very simple, but just I want to use his notation, so I go back to the mean sea level. Let's take a look. Okay. Here are some of the result. Here's some of we used to be after this one we pretty much finish our story because I promise you we'll finish all this one. Apart from this one maybe it's not important. This one probably we use this one as well because the one is a slope one probably is this one. We probably use this one as well. But anyway, let's go back to the over here. Now let me get rid of all this ugly bit. Okay, so these are we call the mean sea level. So normally this is the one you are interested in. Why you are interested in mean sea level? Because it's universal. It's universal, pretty much universal. Because if you really do the physics bit, you find out mean sea level is universal, unified, but they have some degree difference. So anyway, so you are interested in A prime, B prime, this one. But instead of getting A prime, B prime, there is no way I stand on the sea to do this kind of measure. So instead you stand on ground, but you do some correction. Okay, how are you going to do this correction? And is it time up? I think it takes some time. So maybe we can leave as a for I'll sign your homework. So and we don't talk too much about everything, but so whatever we talk become very important. They become important. But the way we talk sometimes a slight different from books. So if you have any doubts or something we can discuss with like that's a book I think it's not written absolutely understandable because some of the formula something is out of nowhere. So it's better we have our own way to study. Where is it? I think we'll come to the machine bit very soon. So this is leveling. I will come to this is chapter 3. I think chapter 3 is leveling. So next week we can come to the chapter 3. But we'll see. Okay. So homework. Forget about sea level. We haven't talked about sea level. Radius Earth. There's another correction. Forget about it. Others so. The question is depends on how much you solve the question. So we give you some score like from 60 to 100. So first off, we do all this bit. We do the temperature correction and also the poor correction, the temperature correction. But I'll change the number. Otherwise, we do it, but otherwise, you probably just copy everything. I'll change the number. So, the first number I'm going to change is the temperature here. Here is the mean field temperature is 14, right? Now I change the temperature. So please pay attention because once you finish this one, I forget my question again. So please, you have to memorize your question by yourself. Okay, so I change the question. I get rid of 14 degree. Instead, I give you 24 degree. Okay. Now you have to tell me what's the distance. What's the distance for this one? For the force span. Now the force span in total is 119, right? 119.631 in total. So you have to tell me if you are using this tape, what's the temperature? Not the temperature. What's the length of this fall in total? Tell me this one. Otherwise, question 1. Question 2. Pull force. Again, I change the pull force. The pull force I change to instead of 95, I change to 100 and 5. This is a 105. This is the standardized Newton force over here, 105. And here, 145, the same. I don't change this one. And then you do the correction for the pure force, pure correction. And then the third equation, this is the first question. The second question, I calculate the pure correction. And the third equation, is to combine these two together. Put 1, 2. It means you consider both of them. Consider both of them, and then give me the length of LOS. Consider this factor, put them together and see what happens. And so this is the equation. Fourth, set correction. And set correction, I think P here is previously we were talking about P. P here is your exert force, the force, the pure force. P stands for the pure force. So pure force here is 145, right? This is your pure force. Okay, so in this case, I already changed I didn't change the pure force. So whether the solution is the same. Wait, L1, L2, L1, L2, L1 is the L1 is the there we are. So up to question 3, you pretty much can get 60 to 70 points, and another 20 points. 4. If you can understand my question, that's good. 4, the question goes like this one. You have to do the let me see. No, the second one is the same. L1, L2 is the same. I think 4, just like this one. Just redo this bit. I just want to redo. Check this one again. Redo this bit. Probably you don't. The solution will be the same. And the final answer will be this one. Okay, this 4, 5. Last one. Last one. Up to this 4, probably you can get like 60 or 70 points. Another 30 points over here. Another 30 points. You take all of them into consideration. 1, 2, 3, 4. Take into consideration and give me the corrected measurement, the length of these 4 span. So the final one is 1 plus 2 plus 3 plus 4. Put in 4 of them into consideration rather than individually. Okay, let me repeat the question. The question, first of all, you change the force, change the pull, this P to, you don't change P. P is fixed as usual, 145 Newton. P is the same. But you change the temperature, the mean value temperature, the mean field temperature change to 24 degrees Celsius. Also, you change the standardized force from 95 to 105 newtons, and keep the temperature intact. And other conditions are the same. Apart from this value being changed, others are the same. Okay, and now based on this information, first of all, do the temperature correction individually. Only consider about temperature correction. What happened? What's the LOS? Only consider about pure correction. What happened to the LOS? If I put consider about 1 and 2 together, what happened to the LOS? And if I consider the sec individually, what happened to the sec? Final one. If I put 1, 2, 3, 4 all together, what's the LOS? So this is 30 points along. Up to this one, the 70 points. For 1, 2, 3, 4 is 70 points, and the last one is 30 points along because I combine all of them This is a because this book is good in some sense, but in some sense it doesn't combine everything together. It's not good because we want to combine everything. Otherwise, why do we have to learn a bit by a bit? Because we want to combine every of them. Okay. Any question? Any question regarding today's homework or today's lecture? Any? Okay. So if you have any problem, you can just pop your question in our group, and maybe some of you can discuss with each other, or you can discuss with me as well, and then you have some good idea. But make sure you understand the question. If you don't understand, don't lie. Will be so I have no idea about what kind of question I put upon you. So please write down the question message, or you just look back your the video again, then you will find out the question. Just many approaches. One, as long as you are keen to solve the problem. Okay. Any further problem? Yes or no? Yeah, you forget to look at your question. Maybe talking here. Now or what? Because I explained twice, so I don't know whether you just asked or you've been asking this one before. You want me to explain once more, or I already explained? Okay, so you want me to explain once more? Oh, great. Okay, let me explain last time. Take a look at the question. The question itself, other figures all the same, nothing being changed, except this value. Hi, Mark.
Yeah, can you hear me?
Yes.
Okay, I'm asking that you explain the last part, only the last part, like the last part of the question, like combining 1, 2, 3, 4, like what you said, what we should do. Like, can you just explain on that part?
You mean the last part, the 1, 2, 3, 4, is it?
Yeah, of combining 1, 2, 3, 4.
Okay, so the combining 1, 2, 3, 4 is like you take temperature into consideration. You take the true force into consideration. You take the sec into consideration, and then put them together. So into is not 1, 2, 3, 4. Into is 1, 2, 4. Because the 3 already put 1 and 2 together, right? So indeed the equation is supposed to be 1, 2, 4. So you combine 1, 2, and 4. Then solve the equation 5.
Okay.
Is that clear?
Yeah, it's clear.
Okay, very good. Okay. All right. So I think we pretty much finished today's homework, today's job. So if any question, just discuss in the group. If I have time, then I'll try to help you a little bit. But you got to solve by yourself first. If you don't think about it, then no one is going to help you. You got to think about it. Check the textbook and check the video again. So that's it. Okay, I take the class monitor to call a roll, and then we call a day. Okay, so please, those who are absent, please ask them to join us. Otherwise, they really lag behind a long way. They can't catch up at all. So in the end, that causes a huge problem. I don't want any of you being lagging behind. That's not my main purpose. But if you keep on cutting the class, skipping the class, then it causes a problem for yourself. It doesn't come from me, but come from yourself. Okay, see you next time, and please do the homework and ask those who are absent come to the class. So otherwise, they'll have some problem in the end. Okay, see you next time, and that will be next week. Okay, bye.